for this function, I am going to factor. I know that I have a GCF in the bottom of 4x, so I can factor out of 4x, and I have 4x times x minus 2, and then I can see that 4 is going to cancel, the 2 and the 4 will become 1 over 2, and I can get rid of an x, so I'll have x squared and an x in the bottom. And I'll end up with x squared over 2 times x minus 2. So this is my final equation that I'm going to use to find my important info. So a hole, I do have a hole for this graph at x is 0. And so when I plug in 0 into this function, I have f of 0 is 0. That's all I need to do. I don't need to go from there. I have a hole at 0, 0. Which means I don't have a y-intercept. Just FYI, since this would have been my y-intercept. But there's a hole there. Vertical asymptote, I have what makes the denominator 0 there, and that would be 2. So x is equal to 2. That line is a vertical asymptote. Then I want to circle which one of this graph has a horizontal asymptote or an oblique asymptote. I'm comparing the powers in the numerator and the denominator. So I have x to the third power over x to the second power. So I know it's top heavy, and I know that the numerator power is 1 higher than the denominator power. So I'm going to have an oblique asymptote or a slant asymptote. So this just means a slant asymptote, and that's what I'm going to have. And I want to find what line is going to be that slant asymptote. So I'm looking for what line that is, and that's also going to tell me my end behavior. To find what that is, I'm going to divide the top by the bottom. So 4x squared minus, that's the bottom. So yeah, I'm going to divide 4x squared minus 8x into 2x cubed, and I need to include all my powers down to the constant. So 2x cubed plus 0x squared plus 0x plus 0 just helps. It's helpful for me to line things up. And if you don't do that, you'll probably make a mistake. So make sure you do that. You put placeholders in for the x terms or the x powers you don't have. So I'm asking myself, what do I have to multiply 4x squared by to get 2x cubed? I know that I need an x, and I know that 4 times 1/2 gives me 2. So I need to multiply by 1/2 as well. So 1/2 x. I know I need to distribute that 1/2 x to the 4x squared and to the minus 8x. 1/2 x times 4x squared gives me 2x cubed. And then 1/2 x times negative 8x squared. Negative 8 times 1/2 is negative 4. And then x times x is x squared. So I'm going to take this expression and I'm subtracting it from my original polynomial to see what I have left over. And I'm going to be left over with 0x squared plus 4x squared, which is 4x squared. And then I bring down the 0x. And then I'm asking myself, what do I have to multiply 4x squared by to get 4x squared? Oh, that's 1. So I put plus 1. Oh, I don't need to do anything else. This is my line. That's a line now. And so I have y is equal to 1/2 x plus 1 is my slant asymptote that defines my end behavior. So the limit as x goes to positive and negative infinity of f of x is equal to 1/2 x plus 1. That describes my end behavior. Zeros, I'm looking if there's anything that makes the numerator equal to 0, and that's 0 only, but I know that also doesn't exist because there's a hole at that point. So I'm going to plot my important information. I have a hole at 0, 0, so I put an open circle there. I have a vertical asymptote at x is equal to 2, so I put a vertical asymptote at x is equal to 2. And I'm going to make it really long because I probably need to make it pretty long, and I'll make it longer if I need to later. And then I have this line I'm going to graph, and that is, I'm starting at 1. So I'm starting at 1, and then I have I forgot what it was, 1/2. So I'm going up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, and down 1 to the left 2, down 1 to the left 2, down 1 to the left 2, and then I'm going to connect these with a dashed line, and that should be good. And then I'm going to plot important points because I don't have any except for that hole. Well, as I go to the left, actually, yeah, I need to check points. Let's check points. So I'm going to check, I'm going to make a table. I'm going to pick a point to the right of that hole. So I'm going to pick x is 1 to see if I'm going up or down. So when x is 1, I know that, God, I wish this was not so zoomed in. Okay, x is 1. I have f of 1 is equal to 1 over 2 times 1 minus 2, which is negative 1. So it's 1 over negative 2, or negative 1/2. And so 1 and negative 1/2 is what I have right here. Okay, so I know I'm going downwards as I approach the vertical asymptote. So as I go to the left, I know that I am going to be approaching, since I won't be going through the x-intercept anywhere else, I won't be going through the x-axis anywhere else. I know I'm going downwards and approaching the slant asymptote. On the right, I have, I want to plug in a point and see where I'm at. So on the right of that, I have 3, x is 3. F of 3 I have is 3 squared, which is 9, over 2 times 1, which gives me 4.5. So I am doing 3 and 4.5. So 3 and 4.5 right here. And I know as I go to the left, I'm going to be approaching that vertical asymptote upwards since I don't have a repeating factor in the denominator. And then as I go to the right, I'm going to be approaching that slant asymptote, and that's what my graph looks like.